Welcome to this session. In this session, I am going to talk about construction and working of dry cell. Dry cell, also called as Leclanche cell or zinc carbon cell. It is mostly represented as zinc MnO2 cell, zinc manganese dioxide battery. In this cell, anode is the zinc cylinder and cathode is the paste made with manganese dioxide and graphite. Then electrolyte used in this cell is the paste of zinc chloride and ammonium chloride. These two are made into a paste and that is used as the electrolyte. Dry cell is a primary battery. It can be used only once, cannot be used again and again like secondary batteries. It consists of a graphite rod with a metal cap at the center. So here, this is the graphite rod. This is placed in the center, and this acts as the positive terminal. I mean, it acts as the cathode of the cell. This rod, graphite rod, is surrounded by a paste of MnO2 and graphite. So this is the graphite and manganese dioxide paste. Then the outer layer surrounding this graphite MnO2 paste is the electrolyte. That is also a paste made with zinc chloride and ammonium chloride. These two are made into paste either with water or some other suitable gel-like material, and a paste is made. That paste is used as the electrolyte here, and this electrolyte is surrounded by a zinc cylinder. So zinc cylinder, this is the zinc casing, zinc cylinder. This zinc cylinder will surround all these. This zinc cylinder acts as the anode of the cell. So the whole assembly containing zinc cylinder, then electrolyte, then inner layer paste of graphite and MnO2, then inner lying graphite rod. The whole assembly that is wrapped generally with polypropylene or sometimes with cardboard materials also to prevent any leakage. Okay. So whole assembly surrounded by polypropylene or other cardboard materials. This is about the construction of the dry cell, and it provides 1.5 volts. A single dry cell provides 1.5 volts, that is its voltage, and represented dry cell is represented like this. Zinc bar Zn plus 2 salt bridge or separator NH4 plus bar MnO2 bar C. So C indicates here graphite, which acts as the cathode. MnO2 is the paste surrounding the cathode. Then NH4 plus and Zn plus 2. These two are the electrolyte paste. Then zinc cylinder or zinc can that acts as the anode. So this is how dry cell is represented. Next, cell reactions occurring in the dry cell are at the anode. We know very well at the anode oxidation occurs. In this cell, zinc is acting as the anode. So zinc undergoes oxidation like this. Zinc solid gives rise to Zn plus 2 aqueous plus 2 electrons. So 2 electrons are produced at the anode, and chemical reaction at the cathode is the reduction, that is MnO2 solid plus H2O. H2O is present in the paste of MnO2. H2O is consumed along with the 2 electrons. 2 electrons which are produced at the anode, they will flow towards the cathode and they are consumed at the cathode by MnO2 and forming MnO2, Mn2O3, I mean manganese oxide. This is manganese 3 oxide. MnO2 is manganese 4 oxide. Mn2O3 is formed, which is a solid. Along with that one, two hydroxyl ions are also produced, which is uh, hydroxyl ions are also produced. So these two are the main reactions occurring at respective electrodes. Some secondary reactions also occur here. One of the reactions is NH4 plus ions, which are already present in the electrolyte paste. They combine with the hydroxyl ions, OH minus ions. OH minus ions are produced at the cathode. They combine with the NH4 plus ions which are already present in the electrolyte, forming ammonia, which is a gas, and water molecules, H2O. Okay, this ammonia gas which is formed now, thus that will disrupt the flow of current. So disadvantage of ammonia gas formation is ammonia gas that will disrupt the current flow. So this will be prevented. This disadvantage is overcome by a chemical reaction between the zinc ions, Zn plus 2 ions, which are produced at the anode. They combine with ammonia gas molecules, NH3 gas molecules, along with the chloride ions, Zn plus 2 ions and Cl minus chloride ions. They combine with the ammonia gas molecules to form a complex that is zinc ammonia complex, that is Zn NH3 taken twice Cl2 complex, which is a solid. Okay, so ammonia gas formed that will be made inactive by the zinc and the chloride ions by forming a complex. So we can write the overall reaction in the dry cell as zinc solid plus 2 NH4 plus aqueous plus 2 Cl minus aqueous plus 2 MnO2, which is a solid, gives rise to Mn2O3, which is a solid, plus Zn NH3 taken twice Cl2, which is a solid, plus two water molecules. So this is a forward reaction, and we know very well dry cell is a primary battery, primary cell. No reverse reactions occurs here. It is only a primary battery. It cannot be used again and again. Next, advantages and applications of dry cell. Applications. So dry cell is suitable for portable electric and electronic devices. Portable electric and electronic devices, this is very much suitable. Portable devices like lightning photographic equipment, some computers, communication equipment, watches, calculators. So in these appliances, dry cell is used. And advantages, a dry cell has good shelf life, reasonable power density, low cost. It comes in low cost, cheaper compared to other batteries, and reliable performance, and also readily available. So available, it is readily available, cost is low, reasonable power density, and a somewhat good shelf life. These are the general advantages of dry cell. And another advantage is that efficiency of this dry cell is high generally when we use the battery, when we use the dry cell under 40 degrees centigrade temperature. So below 40 degrees centigrade temperature, this is efficient. Dry cell is efficient. Okay, so these are the advantages and applications of dry cell. Then limitations of dry cell. Capacity of the dry cell is low, and this is not suitable for high drain applications. So high drain applications like driving electric motors, so they, for such applications this is not suitable. The reason is that if we use for such applications dry cell, this will polarize readily, easily this gets polarized, and available capacity falls sharply with the increased discharge rate. So when we start using dry cell for high drain applications, the capacity falls sharply, and the battery gets polarized. Okay, so this is a disadvantage, a limitation of dry cell. Next one, another disadvantage is this is not chargeable. So other batteries, I mean rechargeable batteries, we can use them again and again, but this can be used only once as this is a primary battery. Next, shelf life. Shelf life of the battery is not especially long, so we cannot store the dry cell for longer periods. So without using, we cannot store this dry cell. So this may undergo self discharge. Okay, so shelf life is not especially long. That is another limitation of dry cell. Next one, next limitation is the optimum temperature range is between 20 to 40 degrees centigrade. So we can use this dry cell between temperature 20 to 40 degrees centigrade only. So below 20 or above 40, its performance falls down. Okay, its performance falls down. So these are the limitations of dry cell, and this is about the construction of the dry cell reactions occurring in the dry cell, advantages, applications, and limitations of the dry cell. Thank you.